Welcome to Renaissance Charge Videos. I'm Rick Friedrich. Today we're talking about sympathetic resonance can provide unlimited energy. So in this video I'm going to refer you to other short YouTube videos at specific times. At such times simply stop the video and copy the link in the introduction area of this video and open a new window to watch that video. Then return to continue with this video. I will number them 1 to 8 as we come to them. Instead of me trying to copy somebody's video and put it in my video and then get it copyright flagged, I'm not going to do that. So this is the easier way to do it. So I hope you don't mind. Now the purpose of this video is to give examples of acoustic sympathetic resonance as an analogy to magnetic and electrical resonance. This study is the most intriguing of the physical sciences, and I trust this video will open some doors for you. This is but a brief outline of certain parts of the subject that I just threw together today. I'm sorry I don't have time to do a thorough presentation on the subject. So, Don Smith wrote the following words some 20 years ago. Useful energy occurs as a result of imbalances of ambient and is a transient phenomenon. In the electrical field, it is a closed system subject to heat death, which severely limits its utility. The flip side of the electron produces magnetic waves, which are an open system, not subject to heat death. These waves, being unrestricted, are the universal source of energy, so he says. When resonant, unlimited duplicates from this one source are available. Therefore, the key to unlimited energy is magnetic resonance. Nonlinear and open systems are universally available in magnetic resonance systems. Explosions of any sort includes atomic. Combustibles of any type. Mechanical equivalents would be levers, pulleys, and hydraulics. A highly obvious example is the piano, where the keys impact the one note, giving one sound level, which resonates with its two side keys, providing a much higher level. Magnetic resonance energy clearly amplifies itself, demonstrating more energy out than in. Ohmic resistance does not apply to magnetic resonance, which travels unrestricted for great distances. Therefore, multitudes of electrons are disturbed, whose backspin translates magnetic into usable electric energy. End of quote. So we talked here about the piano keys, and that's one of the things I want to focus on today. I don't have a piano to show you, but I will show you some videos. So let's start off with a very simple demonstration of resonance in a ball. So look to video number 1 in my introduction of this video for the link now, and just pause the video now and watch that. It's a very short video. So it's just with the ball. So that is the basic illustration of resonance, or at least one form of it. So Wikipedia gives the following definition. Sympathetic resonance or sympathetic vibration is a harmonic phenomena wherein a formerly passive string or vibratory body responds to external vibrations to which it has a harmonic likeness. The classic example is demonstrated with two similar tuning forks, and I've got 4 here, of which one is mounted on a wooden box. If the other one is struck and then placed on the wooden box, then muted, the unstruck mounted fork will be heard. In similar fashion, strings will respond to the external vibrations of a tuning fork when sufficient harmonic relations exist between the respective vibratory modes. So that's just a very brief understanding that Wikipedia is very committed to the conventional theories of physics and electrodynamics. They often leave out important facts that contradict their statements. However, they also sometimes publish facts that contradict their conventionally biased publications. And that's where people mostly are inconsistent in life. So let's turn to video number 2, which is a very interesting video of a number of aspects of tuning forks again, and amplification. So you can stop this video and watch that right now. So notice how the tuning forks, so it's top 10 demonstrations with tuning forks was the video, right? So notice how the tuning forks influenced each other. So let's look at that a little bit here with our little oscilloscope. Now I have a piezo here that I took off of one of my damaged voltmeters that I damaged the other day with high voltage. And so we're using that as a speaker, and we're going to attempt to do this. I'm going to use the tuning fork and place it okay. So we can see, hopefully you can see this. Looks like you can. So I'm going to put it on, there's 2 layers on this piezo. There's the side that's touching the wood box. So you can hear, I've dampened this and it still continues. So let me get on the top layer now. So it continues on even after I stop. Now, I don't have the desired tuning forks. These are very small, and the ones that you see on these videos here that I'm bringing out, they have much bigger mass to them, and so you can more readily notice the vibrations. But they do demonstrate it. So you can hear the tuning forks continue on, they influence each other. And what I want to bring out in this, so this represents like a guitar without strings, or any kind of wooden instrument, amplifies the sound. So now what I want to talk about a little bit is these piezos. They convert vibrations into electric, and they're not really affordable for the amount of power they can put out, but they also reverse our speakers. They will convert electrical to sound, so either way. Now, where they are useful are with very fast high or really high frequency vibrations. So if we create this effect of creating vibrations very easily with very little input, then we can produce enormous amount of energy output in that alone. I'm not really getting into that, but it's just kind of a side point. But the point I want to show is that with very little input, like the best thing to look at is the piano, because there's so many strings that are influenced in one device, one instrument, that it is remarkable how much resonance takes place. And that's what we're going to look at in these videos. But I wanted to show, like I was actually trying to find, I spent the good part of the day looking for videos on this subject and showing the amplification aspect, which is what I found very interesting. Was people were talking about the basic idea, but very little got into the whole how this could be amplified and what it really implies. Like when you figure, I mean, I hesitate to say too much lest I speak incorrectly about the subject, but the idea of these oscillations at resonance is an amplification, is an over-unity process. And I've shown that with the Benitez system with these induction coils. Well, I'm not going to bring them out now. If you look at my videos a year or so ago, where Carlos F. Benitez 100 years ago was able to use the induction coil with the interrupter, and as there's a transformer in the interrupter, there's a primary and secondary, and as the little interrupter turns off the input into the system, the primary and secondary coil oscillate back many times, and each time they fill up this capacitor and dump it across actually the input battery, input and the output battery at the same time. And what happens is this actually goes to recharge the system and produce all the necessary power to keep the whole thing running while running an external load. So there's several patents and additions to the first patent that go over that. And so in the same way, like we see this acoustically, this resonance, that enormous amount of extra energy is produced with one single strike. And it doesn't have to be so clumsily as me hitting it like this. It can be done very simply with like a piano key being struck was well devised, very little energy being used to create quite a profound output, multiplied. And so we want to look at the oscillations. Each time it oscillates is a repeat of the energy, but then it's also multiplied not only in itself with individual oscillations vibrating back and forth, but also the other tuned, resonantly tuned objects will resonate as well and continue to resonate within that vicinity. So for very little input, you have enormous amount of potential output, provided your environment is appropriate. It is adapted to that end. So I decided today to go to a store called Elderly Instruments in Lansing, and I got these tuning forks. And while I was there, I got a chance to have a little demonstration. I told the guys what I was planning to do today, and they were helpful. One of the guys happened to have studied electrical engineering, and so he was very interested in helping me out and talking to me about it. So the first section, there's going to be 3 little sections here, is just me introducing the building and what happened. So let's watch it. So I'm here at Elderly Instruments, and we're going to look at the idea of sympathetic resonance in instruments. And I'm looking to get some tuning forks here to demonstrate this in my little video. So I've actually done the video already. I've asked one of the employees to demonstrate this in various instruments, and that went really well. So now the second video was really the first one that I took, but shows a wall of banjos, and they work really well if we were in the acoustically proper room and there wasn't a lot of noise. So there was in this case, but you could still see it. And the idea again is to pile up all these instruments all around and then just see how they're all turned on by one note or one strum of the banjo. Okay, go ahead. So we have this sympathetic resonance effect here with the banjo affecting other banjos. Now we're not in the proper room for it, but try it again. So you can hear several of these, and probably more, but to a lesser extent. So good. So notice that he stopped the strings immediately. He wasn't continuing to resonate the banjo that was being strummed, and yet they continued to resonate. So again, this is not trying to do the best example. The second example, let's go into where we go into another open room that wasn't really proper for this effect, but it still shows it with guitars. So let's watch. So here we have a guitar and a room full of guitars. Right. So all these guitars can pick up this sound here. Let's go. Still going a little bit. Even though there's others playing in this room and the acoustics isn't really great, but great, good. So here we are in the proper room that is not going to be influenced by too much other. So we close the door. We're going to try. You can still hear it. Now, of course, we've still got this humming sound here, but that's fine. Here, let me hold that door while you do it.
Yeah, it doesn't actually have a closer on it.
Let's try it again. And still going. Still going. So we have effect of all these instruments here all at the same time. Perfect. So you can see that even though there was other people playing and talking and it was an open room, you still had this effect influencing these guitars. So then let's watch the third example. Well, it's part of that video, I guess, yeah, where we go into the other room and then we can see, even though it still had some noises from the fluorescent light overhead with its buzzing transformer, and the door was wanting to creep open on us because they didn't have the doorknob, it more readily demonstrated what I'm talking about. So there was quite a few guitars in that room, and yet they all picked up the one signal, if you will. So I found that was what I was looking for to demonstrate, but yet, like I said, when I went to look for YouTube videos, I had seen somewhere, sometime back, somebody doing that, where they showed, you know, one guitar causing all the other guitars in the room to resonate like that. But so I find it interesting that though people are talking about this, they're not really showing the amplification side of things. They're just talking about the bare fact that you can resonate one object from another. Well, what about multiple objects? Now, they are talking about that in the piano, which definitely does that, but would it be interesting to see a whole bunch of pianos resonating each other, you know? So there's a lot of examples of this sort of thing that people are well familiar with, but they just don't really compute it in their minds, the possibilities, or what the implications are of this. That's why I wanted to bring out this in this video. So here's another book. I'm not saying I endorse this book or anything, but it was just something I found on harmonic resonance. So again, it's kind of similar, harmonic and sympathetic. Sympathetic, I keep saying it wrong, is you know, a synonymous term in this case. So harmonic resonance is an extraordinarily diverse and varied phenomenon seen in countless forms throughout the universe. From gravitational orbital resonances to electromagnetic oscillations, which is what we're interested in, of course, to acoustical vibrations in solids, liquids, and gases, to laser resonance in light and microwaves. Harmonic resonance spans a vast range of spatial scales, from the tiniest wave-like vibrations of the elemental particles of matter to orbital resonances that emerge from spinning disks of gas and stars. But across this vast range of spatial scales and diverse media, there are certain general properties of harmonic resonance that are all common to all of them. They all tend to oscillate at some characteristic frequency, and it's higher harmonics. Frequencies are integral multipliers of the fundamental frequency. They all exhibit spatial standing waves, right? And I don't have time to get into all explaining every part of this here, so bear with me. They all exhibit spatial standing waves whose wavelength is inversely proportional to their frequencies. They all tend to subdivide 1, 2, or 3 dimensional spaces into equal intervals of alternating reciprocal forces dynamically balanced against each other, with the twin properties of periodicity and symmetry across every possible dimension of space and time. That's quite a loaded statement. These and many other properties are properties of resonance in the abstract, manifested across all those diverse forms and media. Harmonic resonance is a higher order organizational principle of physical matter that transcends any particular implementation in the physical medium. Now this guy gets into a whole bunch of things in his book. I was just looking at that quote, and he gets into the whole biological aspect of resonance, which is intricately, it's universally everywhere. It's a fascinating subject. It's like I said, one of the most fascinating subjects of all of the physical sciences. So let's go to video number 3, sympathetic vibrations of the second and third harmonics demonstrated on an upright piano. So watch the video now. So that gives you another depth of understanding by starting to look at the piano. We're only going to start with the piano, that video, and it's actually kind of stage 2 in this, where you're getting to the second, third harmonics and all the all the harmonics of it all, and so it's just kind of a brief demonstration of that, and you can get into all that and figure that out, and that's where it is necessary to know some of that to get into the application of this. So anyway, let's go into another quote from Wikipedia. Now I don't even know how to pronounce this. Aliquot stringing is, so that'd be A-L-I-Q-U-O-T, stringing, is the use of extra unstruck strings in the piano for the purpose of enriching the tone. So adding yet another string. So these systems use an additional, hence fourth string in each note on the top 3 piano octaves, because the lower ones I guess only have one string. This string is slightly higher than the other 3 strings, so it is not struck by the hammer. Whenever the hammer strikes the 3 conventional strings, the Aliquot strings vibrates sympathetically. Aliquot stringing broadens the vibratory energy throughout the instrument and creates an unusual, complex, and colorful tone. Julius Buthner invented the Aliquot stringing in 1873. It was a good time in history. Because they are tuned an octave above their constituent pitch. True Aliquot strings transmit strong vibrations to the soundboard. This would be like the soundboard right here. And because Aliquot strings are so active, they require dampeners, or they would sustain uncontrollably and muddy the sound. See, they don't want excess energy. They don't want it. They want pure sound. They want the beautiful, colorful sound. They want this reverbing effect, but only to a certain extent. So here we have this additional string that's wanting to keep on going, but they have to dampen it. In fact, I think they got rid of it altogether. If you keep reading on the article, you'll see, or you click the guy's name and you read more on the subject, you see. But the point is, this is the way it is with all these over unity systems that we've had in our products that we've used in our households over the last 100 years. And we haven't even noticed that we've had them. Because the intended purpose for them was not to produce energy, it was produced some particular action. And we wanted that particular thing to work in a certain way. We weren't trying to produce energy with them. And same with music. No musician thinks about these sort of things. They don't care. I mean, they have probably never even considered that. Even though, I mean, I think of that because that's what I'm involved with, right? But here's an example of just simply adding another string. Just like I say with my battery charges or my motor systems, the more batteries we have charging, the more we get out of them. The more charge takes place. So here, adding another string is going to create more action. And it's not that we're using up the primary source. In other words, we're not depleting the source by adding that. I mean, yes and no. We are, when it comes to acoustics, that would have a very small diminishing effect with its environment. Like, in other words, this will be affected by everything in this room, either favorably or dampening. Now, adding another string, in this case, really is actually enhancing the primary. It's enhancing it because they're both vibrating together, and then while this has excited this, it tends to multiply the effect out, just like all those guitars. I mean, if you had a really tight room, you would have the effect more in other words, the oscillations will not be diminished by the second string, you know, depending on how well it's made and so forth. But my point is, by adding that, you're multiplying the effect. Whereas you have these, what do they say, dampers in there to stop it. We're going to read Tesla about resonance and pure resonance and how the environment actually prevents pure resonance because of all of the natural dampeners. So, but the point is, there's so many oscillations, there's so many reverberations and echoes, if you will, that are coming back. These oscillations, there's so many of them that you can just literally periodically add a little input and then it comes back to you. Like, in other words, you take a little dip out of the ocean and you get a big wave covering you in the proportions. So now let's go to another very interesting video. So video number 4, piano sounds never heard before. This video is about the surprising sounds that occur naturally in acoustic pianos, revealed clearly for the first time by the harmonic pedal. Yes, a fourth pedal. When the harmonic pedal is applied, you hear only the sympathetic resonance of the other strings that are not being played. These you would normally hear with the notes being played, which are more dominant. So watch this video. Alright, assuming you watch the video, it's amazing. This is what you're hearing beyond the notes being struck, the background, and it's beautiful. It really is. It's an amazing instrument. In its complete design, it was incredible for them to have made that instrument. But this is a new feature now that I don't know how available it is, but that you can just kind of dub out the primary notes and listen to the rest of it being played. So again, what you hear in that video is all the extra that's free. In other words, it's all this sympathetic resonance. So let's go to number 5. This is another really interesting video. Sympathetic resonance with 32 metronomes. Now, these are what is a device that produces an audible beat, a click, or another sound at regular intervals that the user can set in beats per minute. Musicians use the device to practice playing to regular pulse. Now, when I was, I don't know, 8 or 10 years old, I used to play the piano, and I remember this click, 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 back and forth. So now, here we see 32 of these metronomes start off out of sync. Like the guy starts them off out of sync with each other, right? And then after a short time, like a minute or two, they all synchronize to the same frequency. I mean, they're probably at the same frequency, but they realign each other. Even though they're out of phase, they realign each other to be in sync. Click, 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 click. This is very important to consider. It's extremely important. It's a very good video. So watch that. Alright, so now let's go into some serious problems with this phenomena. So let's go to video number 6, the Tacoma Narrow Bridge Collapse. The Tacoma Narrows Bridge Collapse. So you can watch that video. This is 1940, and this is an example of poor designing, not factoring in wind triggering resonance. They probably only considered the wind and temperature factors without considering how resonance can expand to a catastrophic degree. So when you think of this, I think people would want to make it out like, oh, it was just strong winds, blah, blah, blah. But you can see how that thing was flipping around. Nobody would have ever made a bridge so flimsy, even in the 1940s, but simply didn't take into account the resonance factor. And you could see how that thing was just wobbling like a noodle because of the tremendous forces, not because of the strength of the wind. It was the resonant frequency of the bridge. So they need to consider how to build, So anyway, let's go to video number 7. Scary, massive waves on a huge road bridge send Volgograd drivers asphalt surfing. So another example where you can see the same waves on a bridge. These are not rubber bridges. They're not noodle bridges here. This is not, poorly, like, these are strong, hard bridges, but they're not built right because they're not taking consideration the resonance factor. The wind alone cannot cause this like it would a sheet of fabric or a wet noodle. But the wind can create the resonant frequencies of the bridge that cause this very powerful effect. bridges must be built in a way that prevents this from happening with multiple dampeners and other means. Just like the piano. We don't want too much power here, right? Now, of course, you could always create a lot of these, right? And you could allow some, whatever. There's a lot of potential. So, of course, this leads me to bring to the question, or you are probably going to ask, so what about Tesla's earthquake machine? So see number 8 video. Tesla's mechanical oscillator in works, earthquake machine. So look, this is like some plastic or glass case from obviously a long time ago from this museum, and it's quite fascinating to see it. We don't really get to see it too clearly. I suppose if you go to their website you might see more, but I just found this video and I thought it was very interesting. He writes, this is a functional model of Tesla electromechanical oscillator during operation. This device is also properly called earthquake machine, as it produces mechanical oscillations to the surface it is installed on. I don't think they speak English properly, but Tesla patented this device in many forms. Liquid of gas being used to produce mechanical oscillations. Electrical power to produce mechanical oscillations, or mechanical oscillations to produce electrical power. So there's two machines there. One to create the vibration, the other one to just like this little device here. That is why it's called reciprocating engine, or geotel dynamics, the means of transmitting messages through the earth. So, done with the videos. Let's take a closer look at what Tesla actually did with this technology and what he dreamed about doing it with it. So in volume 21 of Hearts magazine, The World Today, which was published from July 1911 to June 1912, there's an article by Alan L. Benson titled Nikola Tesla Dreamer, his 3-day trip to Europe and his scheme to split the earth. Now, this is going to reveal that Tesla, again, was not a good boy. He was actually evil. And this is just another example of how, maybe not always the worst example, but it was a pretty bad example of him. Nevertheless, it's very related to what we're talking about. So while on the subject, I'm going to jump past the first part, which is not pertaining to what I'm talking about. So jumping down the first page, second last paragraph says, while on the subject of dreams, here's a Tesla dream that, so far as I know, has never been equaled by Tesla or by any other human being since the world began. Everyone knows that a note upon a violin will sometimes shatter a wine glass in the same room. Everyone knows that a note upon a flute will set some string in a piano softly to humming. This is what we're looking at today. But everyone does not know the reason that underlies both facts. So now we're getting into the amplification of this phenomenon. Right? We're going to see very quickly that it isn't merely that I'm sending out a signal, and the same thing applies to radio, sending out a signal and so many particles or what have you are transferring into the receivers, and that's all you get. And that's the way people are portraying it. That's the way people think about instruments, perhaps, and they don't really do the math and figure out in resonance we have zero resistance in at least pure electrical. Anyway, either low or no resistance. And so you have the ability to multiply the phenomena, and this is what we're going to see. So this is the reason. The violin and the flute, and this is just Alan's description. It may not be very deep, but he gives you some description here. The violin and the flute set the air to vibrating. The wine glass and the piano string are imperceptibly vibrating before either the violin or the flute sounded, precisely as all matter is always imperceptibly vibrating in response to the multitude of noises and shocks in the world, which I don't agree necessarily. I mean, that is no doubt true, but they're vibrating for a different reason beyond those facts. The vibrations of the violin's note happen to coincide with the frequency of the vibrations of the wine glass, as the vibrations produced by the flute happen to coincide with the vibrations of this particular piano string. And the coinciding in frequency, as they happen to do, they produce the same acceleration that a boy produces when he swings someone in an old-fashioned swing. The person in a swing may weigh 20 pounds, and the boy may weigh but 50, and may push it but a pound. But if he times his pushes to coincide with the turn of the swing from him, and keeps adding a pound each time, he will eventually have to stop to avoid throwing out the occupant of the swing. While on the other hand, if he did not time to coincide with the movements of the swing, in other words, if he pushed a pound against the returning swing each time it came back, the swing would soon stop. So now, there's a limitation, and that analogy is not necessarily showing you the amplification effect. It's just showing you an additive effect over time, slowly building up. So I'm not sure if it's exactly the same. It is an example of resonance. But anyway, the wine glass that is broken by a violin's note is broken because the vibrations of the air that are produced by the violin happen to be the same frequency as the vibrations of the glass. In the beginning, the glass is expanding and contracting only within infinitesimally small limits. But each time that the glass begins to contract, the vibrations produced by the violin gives it a little push. After thousands or millions of such pushes, the expansion and contraction of the glass are so increased that the glass breaks. Fair enough. The principle embodied in this experiment interested Tesla, and he determined to try it upon a larger scale. Now this is where I'm saying, well, hold on. He ordered from a steel company a steel link, 2 feet long and 2 inches thick. He was careful to specify that the steel should be of the best quality. As a matter of fact, the link was strong enough to bear the weight of hundreds of tons. Right? Tesla fastened this link, an electric vibrator, no longer than an alarm clock, but so constructed that the frequency of the vibrations would be altered at will. He set the vibrator to going and then began to vary the vibrations for the purpose of getting the vibrator in tune with the link. For a long time, nothing happened. So even with him, guys, nothing happened at times. So don't give up. Don't think that it's all going to come together for you instantly. But don't try this at home. So then, the vibrations of the link and the machine did not chance to coincide. But at last he got them together. The great steel link began to tremble, increased its trembling until it dilated and contracted like a beating heart and finally broke. This 2-inch, 2-foot piece of metal broke just with this little device. Sledgehammers could not have done it. Crowbars could not have done it. But a fusade of taps, sorry, this is really hard to read here. No one of which could have harmed a baby did it. Tesla was pleased. He had learned something. He wanted to learn more. He put his little vibrator in his coat pocket and went out to hunt a half-erected steel building. Down in the Wall Street district, he found one. 10 stories of steel framework without a brick or a stone laid around it. He clamped his vibrator to one of the beams and fussed with the adjustment until he got it. So this shows how evil a man he was, that he would just recklessly go out and experiment with something. In this case, he had a good idea of what was going to happen, but he put many people's lives at risk to do this. And you might think it's funny or a joke, but what happens if he had just had a heart attack at that moment and this thing kept going and these people died? You know, you just don't do stuff like this. So in a few minutes, he could feel the beam trembling. Gradually, the trembling increased in intensity and extended throughout the whole great mass of steel. Finally, the structure began to creak and weave, and the steelworkers came to the ground panic-stricken, believing that there had been an earthquake. Rumors spread that the building was about to fall, and the police reserves were called out. Before anything serious happened, I took off the vibrator, put it in my pocket, and went away. Should have been locked up. But if I had kept on 10 minutes more, I could have laid that building flat in the street. And with the same vibrator, I could drop Brooklyn Bridge into the East River in less than an hour. Now comes the dream, or whatever it is. Tesla says that he can split the earth in the same way. Split it as a boy would split an apple, and forever end the career of man. This seems like quite a large order, but see what he says about it. Quote, the vibrations of the earth, he said, have a periodicity of approximately 1 hour and 49 minutes. That is to say, if I strike the earth this instant, a wave of contraction goes through it that will come back in 1 hour and 49 minutes in the form of expansion. As a matter of fact, the earth, like everything else, is in a constant state of vibration. It constantly contracting and expanding. Now suppose that at a precise moment, when it begins to contract, I explode a ton of dynamite. That accelerates the contraction, and in 1 hour and 49 minutes there comes an equally accelerated wave of expansion. When the wave of expansion ebbs, suppose I explode another ton of dynamite, thus further increasing the wave of contraction. And suppose this performance be repeated time after time, is there any doubt as to what would happen? There's no doubt in my mind, the Earth would be split in two. For the first time in man's history, he has knowledge with which he may interfere with cosmic processes. This is crazy. I asked Tesla how long he thought it would take him to split the Earth in two. He said he didn't know. Months might be required, perhaps a year or two. But in a few weeks, he said, I could set the Earth's crust into such a state of vibration that would rise and fall hundreds of feet, throwing rivers out of their beds, wrecking buildings, and practically destroying civilization. I guess this is what this whole Geo movie is about now playing. The principle cannot fail. It is powerful when applied to the Earth as it is when it applies to a wine glass, a string, or a steel link. Anyone who doubts should only bear in mind the illustration of the swing. A small boy, by each time adding a pound to the force with which the 200-pound man swings, can set the man swinging with the force of 500 pounds. It is necessary only to keep adding a little force at the right time. There may be flaws in this theory. Others may see it, I don't. I know that some steamship companies proceed upon this theory, reversing its application, by the way, to keep their steamships in a relative state of equilibrium. Steamships sometimes roll more violently than the ocean rolls, merely because their movements become attuned with the movements of the waves. They're in resonance with the waves. Right? And this is offset by a system of interior water tanks back and forth through which the water is forced out of tune with the waves, thus neutralizing them. Right? The theory works aboard a ship. So all these things are known in actual existing systems. But the general public doesn't realize all these things. The possibility that it might work if applied to the Earth is sufficient to stimulate the imagination, even if the improbability of its application be sufficient to allay one's fears. Obviously that's not going to happen, nothing to worry about there, but it is, these technologies are worrisome in some degree. Anyway, let's look at, so let's end this with a small section from an earlier lecture about Tesla and resonance. And I've already quoted this before, but now it might make more sense to people. So he's finishing up the section on impedance, and he says, in the preceding experiments, I've already had an, oh wait, hold on, let me tell you where this is from. Experiments with alternate currents of high potential and high frequency, February 1892. So again, the impedance section, he ends it by saying, in the preceding experiments, I have already had occasion to show some light phenomena, and it would now be proper to study these in particular. But to make this investigation more complete, I think it necessary to make a few remarks on the subject of electrical resonance, which has to always be observed in carrying out these experiments. So this is where people fail to understand Tesla's technology and the impulse technology, because they're running it out of resonance. And if you don't have resonance, then it won't work. I mean, it will work in a really piddly manner. And he talks about when you're out of resonance, you can do certain things. And people often think they have resonance when they don't, and so forth. I think he gets into that here a little bit. So on electrical resonance, see, now we're moving from the mechanical side, mechanical resonance, to electrical. And we want to think of magnetic resonance too. And I won't have time to get into that. And that's the heart of these free energy systems, is the magnetic aspect of things. as I quoted from Don Smith earlier. So let's get into on electrical resonance. He says, the effects of resonance are being more and more noted by engineers and are becoming of great importance in the practical operation of apparatus of all kinds with alternating currents. A few general remarks. Now, when he says a few, he had intended to show more. He says later on about this lecture, he wanted to share more about the literally infinite possibilities of this phenomena. But the body of people he was speaking to were only going to accept so much from him. And his main purpose was to show them the advantages of the one wire as opposed to the two wire distribution of alternating current. And of course, with the high frequency and the disruptive discharge, the impulse technology. So without trying to overstate his case, he's limited to a few general remarks may therefore be made concerning these effects. It is clear that if we succeed in employing the effects of resonance practically in the operation of electrical devices, the return wire, as a matter of course, become unnecessary. Well, will, as a matter of course, become unnecessary, for the electric vibration may be conveyed with one wire just as well, and sometimes even better than with two. Well, in all cases, pretty much, unless you're not doing it right. The question first to answer is then whether pure resonance effects are producible. Everybody uses the word resonance as if they're assuming, like I keep saying this, they're assuming that you either have resonance or you don't. But now he's mentioning whether pure resonance is even possible. Theory and experiment both show that such is impossible in nature. For as oscillations become more and more vigorous, the losses in the vibrating bodies and the environmental media rapidly increase and necessarily check the vibration, which would otherwise go on increasing forever. Now, this is in nature where things are happening and there's always a balance to prevent it. Like he says here, it is fortunate circumstances that pure resonance is not producible. For if it were, there was no telling what dangers might not lie in wait for the innocent experimenter. Now this was about 20 years before the article I just read with this vibrator. No doubt he came across that either shortly after this time he wrote this, but in that case you have something that you are continually inputting in. Even though it be small, you're still adding that. Whereas in what we find in the creation, that there is always a check to prevent that from just continuously going until the whole earth was gone, right? And when Jesus comes back, no doubt there's going to be some of these effects, and people are going to be like, there's going to be masses of chaos. The people are trying to hide under the rocks. Who knows all the details, but no doubt there's going to be this effect to some degree. So, but to a certain degree, page 341, he says, resonance is producible, the magnitude of its effects being limited by the imperfect conductivity and imperfect elasticity of the media, or generally stated by frictional losses. The smaller these losses, the more striking are the effects. The same is the case in mechanical vibration. A stout steel bar may be set in vibration by drops of water falling on it at proper intervals, and with glass, which is more perfectly elastic. The resonant effect is still more remarkable. For a goblet may be burst by singing into it a note of proper pitch. The electrical resonance is more perfectly attained the smaller the resistance or the impedance of the conducting path, and the more perfect the dielectric. All right, that's well known. Okay. But have people really considered the gains? In order to make reliable observations of electric resonance effects, it is very desirable, if not necessary, to employ an alternator giving currents which rise and fall harmonically, as in working with make and break currents, and observations are not always trustworthy, since many phenomena which depend on the rate of change may be produced with widely different frequencies. Even when making such observations with an alternator, one is apt to be mistaken. When a circuit is connected to an alternator, there are an infinite number of values for capacity and self-induction, which in conjunction will satisfy the condition of resonance. So there are in mechanics an infinite number of tuning forks which will respond to a note of a certain pitch, or loaded springs which have a definite period of vibration. But the resonance will be most perfectly attained in that case in which the motion is effected with the greatest freedom, the highest amplitude, so forth. Right? Now, in mechanics, considering the vibration in common medium, that is air, is of comparatively little importance whether one tuning fork be somewhat larger than another, because the losses in the air are not very considerable. One may, of course, enclose a tuning fork in an exhausted vessel, and by thus reducing the air resistance to a minimum, obtain better resonant action. Still, the difference would not be very great, but it would make a great difference if the tuning fork were immersed in mercury. In the electrical vibration, so now mercury was used as an interrupter for extremely fast oscillations, where they had it was in a tube, the mercury, and then it was an electrolyte, the transmission of the pulse, the spark gap was replaced by that for a high power. And so mercury was used quite a bit as a very effective means in that regard. So now, no, I lost my place. So let's go back then. The greatest freedom. Magnitude of the resonance effect depends, under otherwise equal conditions, on the quantity of electricity set in motion, or on the strength of the current driven through the circuit. But the circuit opposes the passage of currents by reason of its impedance, and therefore, to secure the best action, it is necessary to reduce the impedance to a minimum. It is impossible to overcome it entirely, but merely in part, for the ohmic resistance cannot be overcome. But when the frequency of the impulses is very great, the flow of the current is practically determined by self-induction. Now, self-induction can be overcome by combining it with capacity. Inductance, inductor, capacitor. If the relation between these is such that at the frequency used they annul each other, that is, have such values as to satisfy the condition of resonance, the greatest quantity of electricity is made to flow through the external circuit, then the best result is obtained. So it is possible to eliminate that loss entirely. And this is where I get into this on the third stage process, that we can actually multiply this output energy as much as we want and have a whole network of powering loads. We shall have no need to okay, this is the end quote here. This is not even from the same place. It's a different article altogether. So let me just finish by saying, with the resonance part, that when we're in resonance, we don't have the losses that we normally have. Normally we don't operate our systems in resonance. There are certain things that we do and we don't think about because we're used to it, but normally our electrical systems are not in resonance, or only some parts of them are used in resonance. So we're actually not benefiting as much as we could, and that's by design, so that you don't have it too good, you know. And maybe for convenience, you're after one particular, like for example, there's thousands of patents pertaining to the production of light, which are over unity examples, where they're producing far more output than the input, and yet it's not that they're trying to do that, they're just trying to produce as much light as possible for the purpose of photography and what have you, for these light processes. So, and then the engineers either ignore that or don't draw attention to it on purpose or what have you. But the point is, you as the consumer want a given result. Photography, you want the TV screen, the old boob tube. You didn't care about how efficient it was or how much amplification was taking place. You didn't even know about it, but it was still producing this extraordinary process that wasn't being drawn attention to. It still really isn't. So what I'm saying is, we have in music, as I've brought out in this whole video, the example of resonance being, you know, absolutely required process to make it work in all these instruments and even our voice. And so we've come to accept it and use it, but not figure out the implications of it. Now the piano was, as I said, one of the most, the best example of this, and so it was really the most efficient device of multiplying an output for very little input. And it was so beautiful too. But that's not, the point was to make it beautiful and practical. It wasn't to demonstrate, hey, we can have, this proves we have more output than input. You know what I'm trying to say here is, so let's look at this last quote. I forget where it's coming from here. But we shall have no need to transmit power at all. Ere many generations pass, our machinery will be driven by a power obtainable at any point of the universe. This idea, page 236, this idea is not novel. Men have been led to it long ago by instinct or reason. It has been expressed in many ways, and in many places in the history of old and new. We find it in the delightful myth of Antheus, who derives power from the earth. We find it among the subtle speculations of one of your splendid mathematicians, and in many hints and statements of thinkers of the present time. Throughout space there is energy. is this energy static or kinetic? If static, our hopes are in vain. If kinetic, and this we know it is, for certain, then it is a mere question of time when men will succeed in attaching their machinery to the very wheelwork of nature. So that's what I'm getting at, is the bottom line. The wheelwork of nature, which has obviously been quoted many times, that phrase, harvesting the wheelwork of nature. Think about it. What does that mean? It means, like I keep bringing back, the idea of, do we want to learn how to fly? Do we think it was possible for man to ever fly in the air? Well, people said, no, mathematically it's not possible. These are the equations, right? That's what we keep hearing. This is the theory. This is the fact. These are the laws, right? And yet, birds were flying. So, big birds. You know, and so why do we not look at the wings of a bird and examine and realize the basic geometry that allowed for that? Why was it? Because we have our presuppositions, our assumptions. We have our fears and our worries and our pride that keeps us over-assuming and under-assuming, being credulous and incredulous, rather than being just realistic, trusting our senses as God has given them to us, right? And not saying, well, we need to disbelieve things, or we need to just assume something else. And so the attaching to the wheelwork of nature is looking at it as it really is. Like, let's look at the biological processes of the body of plants, of animals, and see how they really work, and apply that to electrodynamics. And what I'm trying to do here is an analogy between the acoustic, which for some reason they're limiting this term, sympathetic resonance, only to the acoustic. Why not to other aspects of things? And that's what some have done in other words, perhaps. So I'm just showing by analogy, we could make a vibration device, for example, and utilize existing materials to transpose this energy. You know, taking a big, huge steel bar, size of this house, and vibrating it with very little input energy, just by very small oscillations with a very small device, you could harvest enormous amounts of energy from that in various ways. You know, causing this thing to break apart. You know, if you're taking milliamps to do that. So now what we do, I'm not going to demonstrate this right now, but with the magnetic side of the resonance, so say you have a primary coil, say it has one wind on it, and it's a very fast oscillation, and it's a very small input, very small, milliamps of power, to very fast. And then we have a secondary coil with multiple winds. If we construct that in resonance with each other, right, it's a fully resonant process, and we construct it right geometrically, in the right relationships, we can have a multiplication of output. In other words, with a very little device, we can set in motion a very big object, a very big output, just by a very little input, because the two are not coupled like induction. They're not transferring power from here to there. It's transmission of a signal. This one produces a louder sound. Anyway, a very little signal in resonance with something very big, like could have brought that big 10-story building down. You do the math. It doesn't add up because it's not, the energy coming from the building wasn't coming from that device. That device was merely sending a signal. This is what I'm trying to say in simplest terms. It's sending a signal for the device itself, which acquires its own energy in its own personal environment. And that's the way you have to understand it. This whole idea that we're transferring electrons from here to there, like with radio signals too, is not true. Each area is receiving the energy, like the last video that I was showing, from the local environment. However it's done, we can't observe that. We don't know exactly the details. We don't have to know. We can know that it happens because resonance proves it. All your theories go out the window with resonance. You have all these Ohm's law limitations, and then suddenly you're in resonance, and now we have negative resistance. We have zero resistance. We have curves that don't line up, right? Partial negative resistance and full negative resistance. Whatever terms you want to use. But when we have the resonance, it's very easily demonstrable to be zero resistance. And when I do my motor systems, we have a echoing phenomena, a negative pulse. Now, why it happens, when it happens, these are all debatable issues. The moment of switch closure, the moment that the coil starts to collapse. Not the collapsing of the coil, the moment the coil starts to collapse and reverse, you have another event taking place. It's a reversal, it's an oscillation back now, and we capture that in a charging battery. Rather than shunting that out across the coil and not using it effectively, we actually get the whole reversal or more. If we have a path of resistance that a load to utilize that readily accepts the energy, again, the resonance factor applies, becomes a negative resistance, and we do some resonance in the battery itself. Or we run other loads. And then, like I show in my third stage process, we can multiply that out again and again. And the point is that we can see this in so many different ways. And the instruments show that to everybody. It shows how these oscillations are not just one beat. There's many. We can see on the oscilloscope how many will take place just on this little device alone, and how it affects many other identical devices, similar devices, bigger devices, without hindering. And in fact, in many cases, multiplying this effect with a reciprocal action relationship. So it's not just the fact that there's multiple oscillations, like we saw with Benitez system, where when the current going into the primary coil was turned off, and now you have these multiple oscillations between the primary and secondary, each time filling up that capacitor. So multiple oscillations, right? Just like this. Multiple oscillations we're tapping into with the benefit of the sound. But here I'm talking about taking another step further. Multiple oscillations with multiple receivers, each doing multiple oscillations. So now we have not just the one being multiplied, we have the many. So with very little input, you can produce a lot of output. So there's many ways to look at this, and this should open a lot of doors. There's a lot of different things that I've covered here that could be tapped into. Just the mechanical vibration alone with the piezoelectric phenomena, which is still a little bit costly, but I've talked about that in several videos already. But when we're talking about mechanical or magnetic and electrical resonance, see, the magnetic is not subject to the decay that you find with electric, especially closed loop circuits. So if we know how to relate the two, the magnetic and the electric, then we can produce as much as we want very easily. But this, I thought, would be an easier thing to demonstrate and show, and let that kind of settle with you, so that you don't have to say, well, give me an example, I want to see this in real life. Well, you've been seeing it all your life, you just haven't realized it. So hopefully this demonstrates some things, you learn some things from these videos. With the piano, I found that interesting. With the key, I learned that today, I didn't even know about it. With the harmonic pedal, the fourth pedal, and to me that's fascinating, and it's such a beautiful demonstration of what I'm talking about. Even though the acoustic is not nearly the same as the magnetic. It's another. The same thing applies, but even more so with the magnetic. And yeah, so I hope you enjoyed watching this. Thank you for watching.